You go to sleep, you close the door behind you, the hallway goes quiet, but the building does not. Every apartment building, every tower, every complex runs on systems that operate continuously, regardless of who is awake or asleep inside. Behind the walls you live in, behind every switch you flip, every pipe you drain, every door you pass through, there is a layer of infrastructure that most residents will never see. This is the story of that layer, not the apartments, not the lobbies, what runs beneath them. Most buildings of significant size are assigned a building engineer, sometimes called a chief engineer or facilities supervisor. This person knows the building the way a ship's engineer knows the vessel, not as a place to live, as a machine. On a Wednesday at 2:17 in the morning, that engineer is already 3 floors below street level, not because something went wrong, because Tuesday's night check revealed a pressure variance in the domestic water riser, small, within tolerance, but worth watching. Buildings like this, one residential towers, mixed-use complexes, large housing blocks, are not passive structures. They consume energy around the clock. They move water constantly. They breathe through ventilation systems that cycle air even when no one asks them to. Let's start with water. It is the most constant system in the building. It never stops. Municipal water enters the building at street level through a single main line. It passes through a backflow preventer, a valve that stops contaminated water from ever returning to the public supply, and then into a holding tank. In most mid-rise and high-rise buildings, gravity alone cannot distribute water to upper floors. So the building uses a booster pump system, a set of electric pumps that pressurize the water and push it upward, floor by floor, continuously. These pumps are equipped with redundancy. If the primary pump fails at 3 o'clock in the morning, a secondary pump takes over automatically. The system is designed to assume the first one will eventually fail, not if, when. The engineer on duty knows the sound of these pumps. She has worked in building operations for 11 years. She can tell when the pressure cycling is slightly off without looking at a gauge. The sound changes subtly, but it changes. The domestic hot water system is a separate loop. Water is heated centrally, in most buildings by a gas-fired boiler or heat exchanger, and then circulated in a continuous loop through the building so that hot water reaches any tap within seconds of being opened. This recirculation loop runs all night, not because anyone is showering at 3 a.m., because the moment someone does, the water must be ready. The system does not wait for demand. It anticipates it. Now move upward through the building. The walls are quiet, but inside them, something is always moving. Ventilation. Every building of this scale runs a mechanical ventilation system, a network of ducts, fans, and air handling units that move air continuously through every floor. In sealed modern buildings, natural air exchange through windows is insufficient. The building breathes mechanically. The air handling units pull in fresh air from outside, from rooftop intakes or facade grills, filter it, condition it for temperature, and push it through ducts into apartments, corridors, and stairwells. Simultaneously, stale air is pulled out and exhausted. On the 7th floor, a resident opens her window at 2:40 in the morning. The ventilation system adjusts. Sensors in the ductwork detect the change in air pressure. A damper shifts, barely noticeable, but the system recalibrates around that open window. Now, the electrical system. A building like this does not use the same power as a single apartment. It runs on a power load that would supply an entire city block, in some cases more. The building receives high voltage power from the utility grid. It passes through a main transformer, often in a ground level utility room or basement vault, which steps the voltage down to usable levels. From there, it is distributed through the building's electrical backbone. Each floor has its own distribution board, a panel that receives power and then distributes it to individual apartments, corridor lighting, and common area systems on that level. The building also maintains its own emergency power system. A diesel generator, typically housed in a dedicated room in the basement or at ground level, is ready to come online within seconds of a utility failure. It does not power everything, but it powers what matters. Elevator operation, emergency lighting, fire alarm systems, stairwell pressurization. The generator is not luxury, it is continuity. The elevator system is its own world. In a building of 20 floors, the elevators do not simply go up and down. They are managed by dispatch software that calculates the most efficient response to every call, simultaneously, continuously. At 3:48 in the morning, one elevator car is parked on floor 12, the last floor it served. The second is on standby at ground level. The dispatch system is waiting. If anyone calls from any floor, it already knows which car to send. Now consider fire safety. The building does not wait for fire. It prepares for it constantly. Every floor has a sprinkler system. Every corridor has a fire door with a magnetic release, held open during normal hours, ready to snap shut if a smoke detector activates. Every stairwell is pressurized so that, in a fire, smoke cannot enter from the floors. Twice a year, the fire systems are tested. Every detector, every sprinkler head, every door release, every alarm zone. The testing takes multiple days and is coordinated with local fire services. It is not a drill, it is a full systems verification. Below the fire system, below the electrical grid, below the water pipes, there is the drainage system, gravity-fed, running constantly. Every time a resident runs a tap, flushes, showers, or uses a washing machine, the water has to go somewhere. Drainage in a high-rise building is managed through vertical stacks, large diameter pipes running the full height of the building, collecting waste from each floor and channeling it downward to the building sewer connection at basement level. Now it is 4:12 in the morning, the building is still running, but something has changed. A building management system, sometimes called a BMS, is the central nervous system of the building. It monitors temperature, pressure, flow rates, power consumption, alarm status, and access logs, all simultaneously. It does not sleep. It does not have a shift. The warning light at 4:12 is a pressure differential alert on the fourth floor corridor ventilation zone. Not a failure, a deviation. The system has logged it, tagged it, and flagged it for morning review. The engineer opens the subsystem log. She finds the cause in 40 seconds. A filter in the fourth floor supply duct has accumulated enough particulate to slightly restrict airflow. The duct is working. The air is moving, but not as freely as it should. The filter will be replaced during tomorrow's maintenance window. The system already knows this. It has already created the work order. The building also manages access, every door that requires a key card, every parking gate, every visitor access point. These are not security features added on top of the building. They are systems the building runs as part of its continuous operation. At 4:47 in the morning, the access log shows 11 door events since midnight. 2 were residents returning home. 1 was a courier dropping a parcel at the building post room. 1 was a maintenance technician entering the plant room. 7 were fire door checks by the building's automated audit system. Down in the basement loading bay, below street level, accessible from the rear service road, the building's waste management system has been active since midnight. In large residential buildings, waste is not simply left in a hallway, it is moved, sorted, scheduled. Many larger buildings use a pneumatic waste system, a network of pipes and suction points that pulls bagged waste from chutes on every floor down to a central waste room in the basement. The resident tosses the bag. Below them, 12 floors of pipes move it. At 5 o'clock in the morning, the building is still at its quietest. The pumps run, the fans turn, the boilers hold temperature, the generator idles on standby, the BMS logs another minute, nothing fails, nothing needs to. The system is designed to carry its own weight. But a building this size does not only run on mechanical systems, it runs on people, on schedules, on decisions made long before any resident arrived. The night shift facilities team typically consists of 1 to 3 people, depending on building size. They are not here because something is broken. They are here because something might break. Their job is presence. One of them has worked in facilities management for 9 years. He spent the first 3 in a shopping center, then a hotel, then this building. He says that buildings are all the same if you learn to read them. Every building tells you what it needs. You just have to listen. At 5:40 in the morning, the first signs of the day shift begin. Not in the apartments, in the systems themselves. The ventilation system increases its output. Fresh air supply rates climb. The lobby HVAC unit shifts from minimum cycle to standard cycle. The boiler increases its target temperature by 4 degrees. The building is preparing for occupancy. It knows what time it is. At 6:15 a.m., the night shift supervisor writes the final log entry. It reads, all systems nominal. Pressure variance on floor 4 ventilation logged for maintenance, no incidents. Handover to day team at 6:30. The handover is quiet. 2 sentences spoken, 1 signature. The night shift ends. The day shift begins. The building continues. Upstairs, the first alarms are going off in apartments. Coffee machines are being switched on. Showers are running. The booster pumps increase their output to match demand. The hot water recirculation loop maintains pressure as multiple taps open simultaneously. In the elevator machine room, the dispatch software is now managing far more calls per minute than it did all night. The peak is 7:20 to 8:10. Departure rush. The system handles it. It was designed for this exact scenario. By 8 o'clock in the morning, the building is fully occupied again. Residents are in corridors. The lobby is staffed. Deliveries have begun. The loading bay is active. The ventilation system is running at full capacity. The building is at peak operational load. And the building does not acknowledge this transition. There's no moment where it switches from night mode to day mode. The shift is seamless, gradual, built into the scheduling logic days or months or years before anyone walked through the door. This is the reality of every building you have ever lived in. Every apartment block, every tower, every housing complex. While you sleep, the pumps run. While you shower, the boilers hold temperature. While you leave for work, the dispatch system routes the elevator. While you come home, the ventilation system has been conditioning your air for hours. None of this is automatic in the sense of requiring no oversight. Every system requires scheduled maintenance. Every piece of equipment has a service life. Every backup needs to be tested. The building runs on labor, most of it invisible. The maintenance schedule for a large residential building can contain hundreds of individual tasks: monthly filter replacements, quarterly valve inspections, annual boiler services, biannual fire system tests, triennial lift servicing. The schedule runs forward on a timeline that extends years into the future. In larger buildings, a dedicated facilities management team or contracted maintenance company holds the service history for every piece of equipment in the building. The boiler that is running right now has a record that traces back to the day it was installed. A building like this one does not merely serve its residents. It responds to them. When the population of the building changes, when multiple floors empty for a holiday period, the BMS adjusts. Energy consumption drops. HVAC zones enter economy mode. The building scales down, and when they return, the building warms up before they arrive. Not because someone pressed a button, because the system was told weeks in advance that the building would be reoccupied on this date at this time. Preparation is built into the logic. There are things in the building that most residents do not know exist. The lightning protection system, the rainwater drainage routing, the building sway monitoring in tall towers, the vibration isolators under the mechanical plant. In high-rise towers, the building itself can move. Tall structures sway in wind. By design, they are not rigid. Rigidity would cause structural failure. The building is designed to flex within precise tolerances, absorbing wind load without transmitting it to the residents inside. The system works until something fails, not if, when. A building of this size will experience a pump failure roughly once every 18 months, a heating element fault once a year, a lift outage several times a year. These are not emergencies, they are planned contingencies. When a system fails, the redundancy engages. When redundancy is consumed, the protocol activates. When the protocol activates, someone is called. At any hour, on any day. The building does not pause for weekends or public holidays. There is a phrase used in facilities management: the building never closes. What it means is that the building's obligation to its residents does not have opening hours. There is no time at which the water can stop, no time at which the fire system can be switched off. Most residents are unaware of how many systems are operating below them, not because the information is hidden, because there is no natural reason to look. The hallway is clean, the water runs hot, the lights come on, the building has done its job before they even noticed it had one. This is not a criticism. It is a design success. The best infrastructure is the infrastructure you never have to think about. When you do have to think about it, when the water is cold, or the lift is down, or the heating fails, you feel the absence immediately because you have always had it. The building engineer, who spent the night monitoring the ventilation pressure variance, leaves at 6:38 in the morning. She walks through the lobby, takes the lift to the ground floor, the same lift she tested last month. It works. She knows why. Outside, the city is beginning. Delivery vehicles, early commuters, the first buses running their routes, and in every residential building they pass, behind every lit window, below every quiet hallway, the same systems are running. Different buildings, different engineers, different maintenance teams, but the same logic, the same systems, the same invisible continuity. We do not often think about what it means to live inside a managed system, but we are, all of us, living inside machines. Machines that were designed by engineers, built by construction teams, tested by inspectors, maintained by technicians, monitored overnight by people who are paid to keep things running while we sleep. There is something quietly remarkable about this. Not the technology itself. Technology changes, but the commitment, the acceptance embedded in the design of every system that maintenance must be continuous, that oversight must be constant, that the building is never finished, it is always being tended. This is the nature of infrastructure. It asks nothing of the people it serves, it simply works. And when it does not, the people inside it feel it immediately. That gap between expectation and failure is the measure of how good the system was. At 11:47 in the morning, the day shift engineer completes the replacement of the fourth floor ventilation filter flagged at 4:12 a.m. It took 11 minutes. The system returned to baseline pressure immediately. The BMS logged the completion. The work order is closed. Somewhere in the building, a resident ran a tap this morning and did not think about why the water was already hot. Another pressed a button and did not think about the software that routed the elevator to their floor. Another turned on a light and did not think about the transformer 3 floors below. That invisibility is not negligence. It is success. The whole point of infrastructure is to become background, to be reliable enough that it disappears. The people who maintain it understand this. Their best work is never noticed. Tonight, the night shift will return at 6:30 p.m. The log book will be opened again. The rounds will begin. The pressure will be checked. The system will be watched. And you will go to sleep. And the building will not. Under this video, there's a subscribe button. It's a small action, but it helps reveal the systems most people never notice. If you're curious about how everyday life actually functions, consider subscribing and tell us, where are you watching from? Have you ever worked behind the scenes of a system like this?